My name is Teklu Hadgu, and my job title at Sandia is I'm a principal member of the technical staff at Sandia, uh, and I do, and my title is actually geological engineering. My bachelor's is in mechanical engineering, which is totally different from earth science or geotechnical. Um, so I had a scholarship to New Zealand, and the scholarship was related to geothermal research. The title of my PhD is uh, PhD in engineering.
Okay.
It's PhD in engineering. I did it at the mechanical engineering department
Okay.
at the University of Auckland in New Zealand. So first I joined the Geothermal Institute, which is part of the University of Auckland in New Zealand, and um, I did energy technology, which is basically earth sciences and engineering. Um, so I had to pick up earth sciences, in graduate school, and also computing. I didn't have a lot of computing experience um, for my bachelor's, so I had to pick up a lot um, at work. Once I started working, and also in graduate school. Um, so, and then I did my PhD in engineering. Um, it's in fluid flow, two-phase flow, but it has some earth sciences in it also. So what happened is I was assigned to work at a geothermal project in Ethiopia. So
Oh,
I was working at a geothermal project at a geothermal field. There was drilling, all kinds of activities. So I applied for scholarship to go to New Zealand because of that and my undergraduate degree. So that's how I end up working in earth sciences. New Zealand is far away, at least in the United States. You can meet all kinds of people from different nationalities. In New Zealand, it's mostly the local people and people from the South Pacific Islands. So it was very different for me. But I was in New Zealand for 6 years. So by the end of it, I felt like I belonged to New Zealand. And then I came to the United States and I did postdoctoral um, at Lawrence Berkeley National Lab and the University of California. So I did a lot of geothermal during my graduate school. So it was mostly geothermal research and nuclear waste disposal on the Yak Mountain project. Are you familiar with the Yak Mountain project?
I am a little bit, but you can absolutely talk about it a little bit if you'd like, if you're allowed.
I can. Yeah, I can talk about everything I do. But the Yak Mountain project, it was a nuclear waste disposal project, and it started in the 80s, but it was stopped in around 2010, about 12 years ago. The Obama administration decided to stop that project. So the project was at Yak Mountain in Nevada, about 90 miles north of Las Vegas. We spent a lot of effort and energy and at the end of it, we went to a license application, but it wasn't finalized. It had to be stopped. Yeah, yeah. But prior to that, I worked on the waste isolation pilot plant in New Mexico, in Carlsbad, New Mexico. So that one is quite successful. It is functioning right now. It's mostly for defense-related transuranic waste. And I worked on that, and it was licensed, and it's functioning right now.
Oh, that's good. That's much satisfying.
Yeah. Okay, so I was at Lawrence Berkeley for over 3 years, and Lawrence Berkeley National Lab is it's together with the University of California, Berkeley. So the funding for geothermal wasn't enough for me, so I had to look for other places, and I was able to get the job at on the WIP project. So at first, I wasn't a U.S. citizen, and at Sandia, you have to be a U.S. citizen for them to directly hire you. So I worked with a contractor to Sandia National Labs for a while. And then after that, I joined Sandia. Sandia has over 14,000 employees. 14,000 employees. And they're mostly in Albuquerque, but there is a campus in Livermore, California.
Okay.
So you can imagine how much research is being done at Sandia.
Wow.
Yeah. So Sandia is a nuclear weapons lab. So it's an NNSA lab, and because of that, there's a lot of work related to that, and homeland security, those kinds of things. There's a lot of work in that, but there's research in pretty much everything, in wind energy, solar, strategic petroleum reserve. So there are people who work. I did a little bit of that a while ago. So there's carbon sequestration in earth sciences. There's geomechanics kind of work. There are different fields. The problem is I have a lot of work to do in nuclear energy, in nuclear waste disposal. So I spent most of my time in nuclear waste disposal and geothermal also. But a lot of other areas I could participate in.
As a research scientist, what does your day-to-day job look like?
Okay, so that varies from day to day, and also on the kind of projects I'm working on. But first, I wanted to say that because of COVID, my work habits changed. Yeah, just to give you some idea. So before COVID, I was working entirely in my office, so I could go and interact with my coworkers if I have any questions, or they can come to me. So there was a lot of interaction with people. Since COVID, it's getting better now. I'm working mostly from the office, but I also work at home, and many people work from home, so there isn't a lot of interaction. So the interaction is basically through Teams. So I wanted to describe two of the projects I'm working on. One of them is Decovalix. Have you heard of Decovalix? It's an international collaborative work. It's called Decovalix. Is actually short for development of coupled models and their validation against experiments. Yeah, so the DOE is participating in this international collaborative project. So several national labs, Lawrence Berkeley National Lab, Los Alamos, Sandia, are participating in different tasks of Decovalix. So the advantage for us is, you see, I don't do any experimental work, but in Europe and in Asia, they do experimental work, and we get to use their experimental work, and we do analysis and model development based on the experimental work. So that's why we're involved in that. So I'm working on two tasks in Ecovalix. One of them is an in situ heater experiments underground, in an underground laboratory in Monterey, Switzerland. That's in Switzerland.
Huh.
Yeah. So we do data analysis and model development based on the data we get, and different teams from different countries participate in the model development, and we meet every 6 months. So because of COVID, it was video conferencing in the past, but now we're back to in-person in different countries, including Canada. So I've been to Canada for Decovalix. Yeah, okay, so that is one of the tasks. The second one is to study the effect of stress and fluid flow on fractures. So this one is based on lab experiments in the UK. So they provide the experimental data to us, and we do analysis and model development. So these are the projects I'm working on right now, and the Decovalix goes for 4 years. Every 4 years, you work on different projects. So 2023 is the last year of the Decovalix 2023. So next year, a new Decovalix project will start. The other thing I'm working on is geothermal research. It's an enhanced geothermal systems. Just to maybe I don't need to get deep into it, but it's just to understand how you can exploit heat underground without. So the typical geothermal field is a hydrothermal field where there is fluid under pressure, and you take that out and use it for different purposes. But for the enhanced geothermal systems, all you have is heat. So you drill 2 or more wells, and you inject cold water in one well, and you try to get hot water from another production well. So as I said, it varies, but in general, so what I do is numerical modeling. For example, for the Kovalex and geothermal projects, I use Tiflotron. Peyton knows about Tiflotron. It's a numerical code. You can do thermal hydrology modeling, fluid flow, groundwater flow. So I do modeling using Tiflotron and COMSOL. So when I use Tiflotron, I submit jobs to machines at Sandia, high performance computing system. We have high performance computing system here at Sandia with a lot of computing capabilities. So I submit my jobs in the evening or in the afternoon. And so in the morning, I checked my runs if they have been completed. Then I do analysis just to see what the output looks like, how good the output is, and then I discuss with my team members at Sandia. We discussed about our experiences so that we can decide what to do next. So that is part of my day. And of course, I have to deal with emails throughout the day. Lots of emails, I have to read and respond to emails. And it may not be in a typical day, but at Sandia, we have Sandia-related meetings. So they have, for various reasons, there are Sandia-related meetings. So I have to attend these meetings. Also, we have weekly and monthly telecons with other labs, with our sponsors, the Department of Energy, to go over the work we're doing. So I have those kinds of work-related meetings. So the other thing I do in a typical day is to document. So they document the results of analysis. And then at Sandia, we have review and approval system. So we have to write on a SAND report. It's called SAND report. And we have to send it for technical review and through the review and approval system before it gets out of Sandia. I go to conferences, so I have to write conference papers and journal papers. So part of my work has travel. I have to travel for the Kovalex and project meetings. So in terms of these reports, so we have milestone reports at the end of the year or the middle of the year. They go to the Department of Energy. So we have to put special attention to them. But we also have research reports. You can, before you publish, you can have documentation. You can have an internal Sandia report. I like to encourage young people to just get into scientific research depending on their interest. And there's no need to be fearful of science and engineering. Once you get to it, it's just a matter of concentrating. It shouldn't be different from other areas. So it's just a matter of getting into it. There are internships at Sandia for college students, and they can go to the Sandia website and look for internships. And one benefit of that is that so you learn how to do research while you're doing the internship. So they have summer internships and year-round internships. And you just learn how to do modeling, for example, how to do the research, and that makes it easier to get hired once they complete their education. The kind of work I do, you may need graduate school education and some kind of experience in how to conduct research, if you can get some experience, but the rest of it comes while you're working. So you learn a lot of the skills at work also. So you don't have to have everything by the time you're done with school. For example, my background is in mechanical engineering, and I had to pick up other fields like earth science, computing, and other things in graduate school and also at work. But it's good to have some kind of internship and maybe while in college to have some research experience. After that, you can apply it to different areas. It doesn't matter whether it's geology or engineering. You can apply those skills. So somebody who wants to do the kind of work I do, somebody interested in numerical modeling, that would require some kind of proficiency in computing languages, mathematics, science or engineering, and nuclear energy. Nuclear energy, it's very valuable. It's going to be valuable for quite a long time. Nuclear waste disposal requires research in many fields. You can be a geologist, a geochemist, or an engineer. You can work in nuclear waste disposal, and it's the same in other areas. I've worked in carbon sequestration and other areas at Sandia, geothermal. You can have a background in science or engineering, and there is something you can do in this area.